All right, let's get right into it. Today, we're tackling something that can secretly turn your super helpful AI into, well, a massive security hole for your entire system. It's a really sneaky problem, and honestly, it's a bit scary. So let's break it down. Think about it for a second. Could your helpful AI actually become a malicious insider? It sounds kind of wild, doesn't it? We see AI as this amazing tool, but what if an attacker could twist it from the inside out? We're going to explore exactly how they can manipulate your large language model to attack your own infrastructure. It's basically turning it into the perfect Trojan horse.
So, first things first. To really get a handle on this, we need to understand the core of the problem. We're talking about a hidden attack surface that has security experts pretty concerned.
And I'm not kidding when I say it's a big deal. The Open Web Application Security Project, OWASP, they rank this as the #5 most critical vulnerability for LLMs. And look, when OWASP puts something in their top 5, everybody, and I mean everybody, in the security world sits up and pays attention. So what are we actually talking about here? It's called improper output handling. And here's the key takeaway. This isn't about the AI suddenly becoming evil. Nope, it's all about how our own applications handle what the AI says. We're basically taking the LLM's response, assuming it's safe, and just piping it directly into sensitive parts of our systems without even checking it first. We're blindly trusting it. And this right here, this is the fundamental mistake so many of us are making. On one hand, we assume the output from our LLM is safe, that it's trusted content. But the reality, since that output can be influenced by users' prompt, we have to treat it just like any other user input, with a ton of suspicion. It's untrusted. And making that mental shift is absolutely crucial to understanding this whole vulnerability.
Okay, so that's the theory. But how does this actually play out in the real world? Let's see how this one little vulnerability can lead to some seriously damaging attacks.
Let's take a super common example. An e-commerce site that uses an LLM to generate product descriptions on the fly. I mean, what could go wrong? Seems harmless enough, right?
Well, here's what happens. An attacker comes along and crafts a very specific prompt. They trick the LLM into embedding malicious JavaScript right inside that product description. So now, every single customer who just views that product page gets their session cookies stolen, or maybe they're redirected to a fake payment site. The impact here isn't just some tech issue. We're talking about huge financial losses and a total, complete breakdown of customer trust. It's a nightmare. Okay, if that first scenario caught your attention, this next one is, well, it's even worse. Picture this, a business intelligence tool. You can ask it questions in plain English, and an AI generates the database queries for you. Super convenient, right?
But what's absolutely terrifying is how simple the attack is. A malicious user asks what looks like a normal question, but they phrase it in just the right way to trick the LLM. It generates a SQL query, but with a drop table command hidden inside. The system, because it trusts the AI, just runs the query. And boom, just like that, your critical data is gone. Wiped out, all of it.
And look, it's not just about these two examples. This single vulnerability opens the floodgates to a whole family of classic, nasty attacks. We're talking cross-site scripting, SQL injection, even command injection that could give an attacker full control of your system. The LLM just becomes a brand new delivery mechanism for old but still devastatingly effective hacking techniques.
So yeah, that all sounds pretty dire. But here's the good news. There is a clear path to defend against this. Let's dig into the industry-standard recommendations from the OWASP Foundation on how we can lock our systems down.
OWASP gives us a really solid 3-pillar strategy. First, zero trust output validation. You trust nothing. Second, context-aware output encoding. You make sure the data is safe for wherever it's going. And third, privilege management. You limit what the LLM can actually do.
All right, let's zoom in on that first one. Zero trust validation. What this really means is you treat every single piece of output from the LLM as if it was handcrafted by a hacker. You have to implement super strict allow lists for what the output can even look like. You verify its format. You put limits on how big it can be. Basically, you build a strong cage of rules around that output before it gets anywhere near anything important.
Now, trying to implement all of that manually, well, it sounds complicated because, frankly, it is. And that's exactly why we're seeing the rise of automated red teaming platforms. These are tools designed to find these flaws for you systematically. We're going to see how they work by using a platform called Verigen as our example. Because this is the big question, right? It's the one every single development and security team runs into. It's awesome to have a framework from OWASP, but how in the world do you apply it across dozens, maybe hundreds of applications, especially when code is changing every single day? Manual testing? It just can't keep up.
And this is exactly where automation just shines. What might take a specialized security team weeks of painstaking manual work, which, let's be honest, is always going to have gaps, an automated platform can knock out in minutes. You get way more comprehensive coverage, and it makes this advanced security testing something that all developers can do, not just a few security specialists.
And we're talking about really deep, specialized testing here. To be effective, a platform like this needs a huge arsenal of attack methods. For example, Verigen uses over 25 different attack patterns that are designed specifically to hunt down these sneaky output handling vulnerabilities.
And a truly comprehensive test has to cover a ton of different contexts. You can see it here. It's not just about plain text. An attacker can hide malicious code in all sorts of data formats. So effective scanning has to check everything, from HTML and SQL all the way to JSON and XML.
So what's the endgame with this kind of automated, super comprehensive approach? The goal is to get to near-complete compliance with the OWASP LLM05 framework. We're talking as high as 95%. That is the level of coverage that lets teams actually feel confident that their AI integrations are locked down against this whole class of attacks. So let's bring this all home. The goal here isn't just about playing whack-a-mole with bugs after you've already deployed. It's about building security in from the very start. It's a philosophy we call secure by design.
And the path to get there is actually pretty clear. You can start with an automated assessment to see where you stand right now. You can figure out the ROI of automating this kind of security testing. And then, the best part, you can deploy your amazing AI innovations with real confidence.
This quote I came across really just says it all. The question isn't if your LLM integrations are going to face exploitation attempts, but if you're going to be able to detect and prevent them. In today's world, attacks are a certainty. The only thing you can control is how prepared you are.
And that leaves us with one last, really crucial question you need to ask yourself. As you weave more and more AI into your products, you have to decide, are you building a secure asset that drives real value, or are you accidentally creating your next, and maybe most dangerous, system-wide liability? The answer really depends on how seriously you take these hidden risks.